Okay, so I'm going to record a video where I do some examples that are relevant to sections 1.1 and 1.2. So this is going to be sort of like the class lecture. It's these videos. I still very strongly encourage you to read the book because like that's going to be very helpful. Like I'm not going to talk about every single thing that's in the book. I'm going to emphasize certain points that I think will help you do the online homework and the things that I think are important. And these videos are you're likely to see the types of problems that will end up on quizzes and tests and stuff. So anyway, let me talk about this one. There's definitely an online homework question similar to this one. We have these two functions, and this one has this more complicated looking formula. This one has a simpler formula. And the question is, are they the same function? In other words, does f equal g? And before we really answer this, there's reason to think that maybe they are the same. We can check that if I plug in, say, I don't know, f of 2, I'll get the same as if I do g of 2. So why don't I just do this? So on the top I've got 4 minus 6 plus 2, which is 0. So f of 2 would be 0. Meanwhile, g of 2, if I look up here, is also 0. So this isn't strong evidence, but what just happened is I just plugged in 2 to both functions and I got the same answer. You can try other numbers besides 2, like you can do f of 3 and g of 3, and you'll find that those are also the same. You can do f of 4 and g of 4, and you'll find that those equal each other as well. So then there's this question is, are they going to be equal no matter what? If I plug in any value of x, is this one going to be equal to that one? So, I mean, that's a real question. Like, you can try to check these numbers one by plugging them in, but of course you'll never check every possibility. Let's do some algebra. Doing this algebra might shed some light on why f of x might equal g of x. Typically, if this thing's going to equal that thing, then I should be able to show it with algebra. One typical trick is that I factor the top, because the top is, so hopefully everybody remembers how to do this. You try to think of two numbers that add up to -3 and multiply out to +2. So those numbers would be a -1 and a -2, right? They multiply out to +2, they add up to -3. And then, so I can tell you what's tempting to do, cancel the x minus 1s, and if I did that and those are gone, then look, it is the same as g. But this is dangerous. Let me explain. I might be dividing by 0 here. That's the dangerous part. As long as I'm not dividing by 0, I can just cancel these things and I'm good. And then f does equal g. But technically, the answer to this question is no. Even though f is equal to g almost all the time, for almost all values of x. The only value of x that's bad is when x is 1. But the fact that there's even a single value of x that causes a problem means the answer is no. F of 1 is undefined. g of 1 is fine. G of 1 I have no problem. I would plug it in and I would get -1. See, up here when I was doing f of 2 and g of 2, and I mentioned that you could also check f of 3 and g of 3, we didn't talk about what happens when you check f of 1 versus g of 1. Maybe we didn't think of it at the time. But, right. So anyway, to make a long story short, this is a typical trick. You have two functions that are equal to each other almost all the time, except there's one of them that might have a division by 0 issue going on. And that can make this function not equal to this function. Because if there's even a single value of x where one of these is undefined and the other one isn't, then they're not equal. So, right. Okay, so let me move on from that. Then we have some online homework, like a question about graphs of functions. So I tried to draw some pictures here. What you want to think about for this is the vertical line test, which hopefully you've heard of it, but I can jog your memory here. Here's the vertical line test. To be a function, it should not be possible to draw a vertical line handwriting is falling apart here. It should not be possible to draw a vertical line that crosses more than once. In other words, if I'm able to draw a vertical line that crosses the graph, and maybe I can give this one away in this case, I can draw this vertical line, and it crosses 3 times. So the answer for this one is no, it's not a function because I'm able to draw a vertical line that crosses more than once. There's other vertical lines, like this vertical line only crosses once, but that's irrelevant. The point is there is a vertical line that crosses more than once, so it's not a function. So let's look at the next one. On the next one, again, there's a lot of places I could draw a vertical line that do cross only once, like here and maybe over here. Then we have something funny going on in this area. What this means is that like the graph of the function came right up to this point, and this is a closed dot. This dot is filled in. This is different from this dot over here. This is an open dot. This one is a closed dot. A closed dot means that there is a point actually right there. So there's a point actually right there, and there's also another point right here because this is also a closed dot, meaning that if I draw this vertical line, and by the way, you have to trust me. I know I'm not a perfect artist, but just trust me that these 2 points are directly vertical of each other. So I'm able to draw this vertical line going through these 2 points. And that's a problem. If it's a function, I'm not supposed to be able to draw a vertical line that crosses twice. So this one is no, again, not a function. And the only problem is this vertical line right here crosses twice. If I just scooted this a little bit to the left or to the right, then it would only cross once, and that would be fine. But the fact that there's this one vertical line that crosses twice means the answer is no. Of course, part C is like a version of part B where I just made that not happen. I made one of these an open dot and the other one a closed dot. So if I draw this vertical line, I would say this vertical line only crosses once because this doesn't count as a crossing because this open dot is not actually a point on the graph. This one is, but this one isn't. And also, if I try to draw a vertical line elsewhere, I'll find that they all cross only once. So this one is yes. Okay. All right, so this video is about 10 minutes long at this point, so I'll keep going. Typically these videos are going to be about 20 minutes long, or I'll just go until I run out of stuff to say. So let's practice plugging some things into functions, and we'll start easy. Here's a function, and we're just going to find f of 2. That just means I replace all the x's with 2's. So 2 times 4 is 8, minus 2 is 6, plus 1 is 7. Yeah, it's as easy as that. The next one is even easier. To do f of a, I'm just replacing all the x's with a's. And then, like I said, it's even easier because there's no way to simplify this. This is just my answer. Like on the last one, I had to actually crunch the numbers and come up with 7, but on this one, there's nothing to do. Yeah. Okay. This one is, well, I don't want to call it hard, but it's not nearly as easy as the other ones. I have to replace each x with an a plus 2. And like I said, I don't want to call this hard, but it's just very possible to make a mistake. It's important to use parentheses when you do this. Like this x, I'm definitely putting parentheses because I have to square this whole thing. Also, as I replace this x, I'm going to use parentheses. And there's danger here too, like if I didn't use parentheses, then I might not realize that this negative sign is supposed to get distributed to the a and the 2. That's another reason why it's important to use parentheses. And then plus 1, so okay. So I copied it all down. And now it's just a matter of simplifying this. Let me do this. To square something like this, like x plus y squared, you should remember how to do this. It's x squared plus 2xy plus y squared. So when I square this, I'm going to keep the 2, I'm going to keep the parentheses, and I'm just going to write down what this squared is. So it's like a is my x and 2 is my y. So I'm going to go, so x squared is a squared, and then I've got 2 times x times y, so that would be 2 times a times 2 plus y squared, 2 squared. Yeah. I will go ahead and distribute this negative sign, so minus a minus 2 plus 1. Okay, let me keep going. Here I've got a 2a squared. Here I've got a 2 times this, which I guess would be 8a, right? Hopefully you follow that. And then I've also got 2 times this, and this is 4, so I would have 8. Minus a minus 2 plus 1. Well, yeah, maybe I should have combined the minus 2 and the plus 1, but I'll do that now. Among other things, I am collecting like terms. So I only see a squared in one place, so there's nothing to collect there, 2a squared. And then I see some a's. I see 8a and a minus a, so 7a. And then I have some just plain numbers. 8 minus 2 plus 1 is 7. So I would leave this as my answer. So like I said, it's not hard. It's just some algebra, but it's definitely more work than part A and B. And on that note, I think I still have time to do this example. This is very similar to one in the online homework. Let f of x be x cubed, x to the third power, and we're going to find and simplify f of x plus a of of course, it's just that. I'm just putting x plus a in instead of x. I use parentheses. Now, on the last one, we used this formula. X plus y squared is this. Now I have something to the third power. Let me show you something. Called Pascal's triangle. I'm sure you've seen this at some point, but I'm making a triangle, and it has one, like, the first row just has one entry, and then the next row has two entries. The one after that has three entries, as you can see, and it's going to go, it actually goes forever. It has ones on the left and on the right, and the way you fill it out, well, on the left and the right is ones, and then the numbers in the middle, like this 2, it's just the sum of the two numbers above it. So 1 plus 1 is 2. So let's fill in the next row. So on the left and on the right, there's going to be ones. There's going to be an entry here, which is the sum of the two numbers above it, so a 3, and then another entry here, which is the sum of the two numbers above it, so a 3. And let's do another row. 1, 4, 6, 4, 1. And like I said, this goes forever. Once you know the pattern for generating these, you can go forever. But why am I showing you this? This formula up here can be seen from this row. What you do is, like, to do, what am I doing here? So, like, we can number these rows off. Where, like, this is, I would say, the 0th row. This is the first row. This is the second row. So if you want to do x plus y to the second power, what you do is you go to the second row, and these numbers just tell you the coefficients, meaning it goes 1x squared, 2xy, 1y squared. If you notice, the power of x, like, it starts off with x squared because this is squared, and then as we go, each term has fewer and fewer x's, and it has more and more y's. So the first term has 2 x's and no y's. The next one has 1 x and 1 y, because the x's went down by 1, the y's went up by 1. The term after that, before there was only 1 x, so now there's no x's, and before there was only 1 y, so now there's 2 y's. And these tell you the coefficients. So what I'm telling you, to make a long story short here, is if I want to do x plus a cubed, I should look on the third row. And I start with 1 times x cubed. Of course, I don't have to write the 1, but I just want to show the pattern. The next term is going to be a 3. And then what do? My x's go down, my y's go up. So now I'm going to have x squared y, right? Because I'm from here, like, the x's go down and the y's go up. So now it's going to just be x squared. And I didn't have any y's, but now I'll have 1 y. Plus, okay, another 3, this 3. And now I'm down to x to the 1 power. Yeah, maybe I should even write these 1 powers. So x to the 1 power, y to the 2 power. And then finally the last one is a 1. And if I want, I can write x to the 0. Maybe I won't do that because the 0 power doesn't do anything. And y to the 3rd. And of course we can write that an easier way. This is x cubed plus 3x squared y. Ooh. All of these y's should be a's. Sorry about that. That's easy enough to fix. A. Okay, for real this time. X cubed plus 3x squared a plus 3xa squared plus a cubed. Yeah, so that's how you simplify something like that. I took a long time to do it, but that's because I was explaining how Pascal's triangle works. Once you know how Pascal's triangle works, you can knock this out in a couple of minutes. So I will leave this video there. I still have more, but I'll just make a new video.